Having thought through the warm-up and looking ahead at the why for today, our target, that's what I really want to make sure you get out of this, is that you can correctly determine how many valence electrons any element has, regardless of which one I give you in the periodic table. You also need to decide if it's going to become a cation or an anion, because what we're going to do today is going to lead us into the next couple of parts, so it's going to be pretty important here, and it's going to continue to build. So the first thing we're going to go over are what valence electrons are, okay? So valence electrons themselves are going to be defined as the electrons in the outer shell. Now, when we think about electrons in an outer shell, we're thinking about, as you should know from other science classes, electrons live in the different shells outside of the nucleus. Okay, so we're looking at electrons in the outer shell of an element. Okay, so I'll try to space this out a little bit here so you can see it. So you want to make sure you have those because those are going to be what we call the chemistry electrons, so the ones that are going to be really involved with all of the bonding, which is what we're building up to. Okay, so valence electrons are electrons in the outer shell. Okay. Now, next would be a definition for the octet rule. So when we talk about the octet rule, we're talking about this idea that electrons exist kind of in pairs as the goal, so they become more stable, but more importantly, they exist as a complete shell for an atom. That's going to make them really stable, okay? So the octet rule is to have that complete shell, they want 8 electrons in the outer shell, okay? So elements want 8 electrons in the outer shell to have a complete shell. Okay, so I'm going to let that continue to go over here so you can see that. So elements want 8 electrons in the outer shell to have a complete shell, hence the octet rule, octet meaning 8. Okay. Now, the idea is there are only a few elements that have 8 in that outer shell to begin with, so they either are going to have less than 4 or more than 4 is how they're going to act when they gain a charge. So we call them cations or anions. So cations are elements with less than 4 valence electrons. Now they're going to lose electrons to meet the octet rule. Just if you think about if you have 3 electrons, you want to get to 8, it's easier just to lose that extra 3 than to try to get 5 more. So that's kind of the idea. So they're going to lose electrons as the bottom line. Electrons have a negative charge. So as they lose that negative charge, they become more positive. And we're going to name them, talk about how we would name them. But you just name the metal and then add the word cation. So magnesium with a +2 charge is called magnesium cation. Okay. Now we're going to go to your periodic table, so hopefully you have that handy, and we're going to get things labeled on here because where they are located tells you what charge they're going to have. So I need to make sure you have these things written on your periodic table because we're going to be looking at this a lot this year. Okay. So above this first column here, the one with hydrogen, lithium, sodium, potassium, rubidium, cesium, and so forth, I need you to write the number +1. That means anything in that column is going to form a +1 charge if it's gaining a charge. The second column with beryllium, magnesium, and so forth is going to be +2. So that example of magnesium having a +2 charge, you would know that because it's in this column, which means it's going to form +2. We're going to skip all the transition metals right now, okay? These guys are harder to know what their charges are because the actual rule is they could have more than one charge, okay? So we're going to come over to this column with boron. So we've got +3. We're continuing, right? So +1, +2, +3 for this column going down here, okay? The next column is going to be weird because they're at 4, which is exactly halfway between 0 and 8. So they could either do positive or -4 because it's just as easy for them to gain 4 as it is to lose 4. So we're going to have to come back to how we tell that, okay? But now that we're at 5, we're going to pick up 3 to get to 8, so -3. This column's -2 for this one right here, -1 for that column. And here are our elements in this last column, these noble gases, they already have 8. So they're not going to do anything, like they're not going to gain or lose any electrons because they're already there. They already have the octet rule, okay? So when we practice this, I'm going to say, okay, look up on top of that column on the periodic table, and that's what charge it has, okay? So coming back here, anions would be the negative half then. So if they have more than 4, they're going to gain electrons, meaning they're taking in more negative charge. We just name them by saying IDE at the end. So instead of saying chlorine, this is now chloride because it has a negative charge there, okay? And you see these charges are written as like basically superscripts, so powers in math, okay? And that's what we're going to be working on. So we're going to practice this here, okay? But there's this little graphic that I kind of like that you might help remember. So cations have a T in there. Cations are positive. There's a T in positive, okay? There's a little picture of a cat. Just a cat. And then the next one, so anions are negative, okay? So think about onions make you cry, so it's a negative thing if you want to think about it that way. That's what the picture's showing. But there's an N for anion. Negative has an N too, okay? So however you can remember it. But let's get down to this practice here. So for the element, we're going to find the charge, if it's cation or anion, and name it, okay? So calcium Ca, come down to your periodic table. Here it is, okay? I'll mark it right here. So we look up at what the number is above the table, okay, or above that column, and it's +2. So that's how I know what the charge is. So I'm going to write +2. Does that make it a cation or an anion? Well, anything with a positive charge is called a cation, so I'll write a C for cation. And to name it, it's pretty straightforward. We're just going to call it calcium cation. So you just literally name the element and add the word cation. Next, with fluorine, we come over, we find fluorine. Here is fluorine. We look at the number above here. Okay, so it's -1. So I'm going to write down that, yep, it's -1. Does that make it a cation or an anion? Well, negative is anion, so A for anion. And we change the ending to IDE. So instead of fluorine, it's fluoride for anions. Okay. Br is bromine. Come back here. I find bromine. There it is. Still in the same column, that's -1. Okay. So I'm going to write -1 for its charge. Cation or anion, again, negative, so A for anion. Bromine becomes bromide. Okay. N is nitrogen. Come over to the periodic table. Here it is. Look at the number above, -3. So I'm going to write that down. -3. Okay. Cation or anion, again, negative anion. To name it, nitrogen becomes nitride. Okay. Kind of change the ending. And then if you would have said like nitrogenide, that's fine. Okay. But nitride is what it's officially called. And aluminum is our last one. So we come back to the periodic table, look at aluminum, look at the number above, +3. So we come back, we say, yep, we know it's +3. It makes it a cation because it has a positive charge. Cations are positive, so C for cation. And we name it as aluminum because that's the name of the element. And then cation. You add that word after, okay? That's it. So what I'm going to have you practice are some basic definitions of what we went over. You're going to practice the valence electrons of the following elements. Okay, so just to walk you through that real quick. The valence electrons from the periodic table go from 1 to 8. Okay, so I will write them up here in green. I'll use this yellow, or I'll use a green highlighter. How about that? So there's 1 here. This column has 2, 3, 4, 5, 6, 7, 8. Okay. Let me just move that so you can see that a little bit better. But when it says valence electrons, it's the idea of, okay, so how many valence electrons does it have? Well, you count to 8. So first column has 1, second column has 2, 3, 4, 5, 6, 7, 8. That's why these guys only have to pick up 1, okay? Because 7 plus 1 is 8, 6 plus 2 is 8, and so forth, okay? So for that one, just to practice that, the first one of calcium, so again, that's over here. So calcium itself has 2 valence electrons. If I would have said, how about sulfur, you would say 6 valence electrons, okay? You don't need to write these numbers necessarily at the top, the 1 to 8. You can if you want, but what really matters are the charges. So the +1, +2, +3, ±4. If you are going to write those numbers there, you might want to make yourself a note, like I can write myself an arrow. That's the number of valence electrons. Because later on, you're going to look at that and say, what in the world are 1 to 8, okay? All right, so you're going to practice last the charge and if it's cation or anion. If you want to practice naming it, you can too, but hopefully see that's pretty straightforward. Okay, so go ahead and give those a try, then you'll check them, right? Then you'll try a mastery check on it.